Okay, our first problem in chapter 5 is if a 1.5 kilogram sample of water has a heat absorption of 2.0 times 10 to the 4th joules and a specific heat value of 4.184 joules grams to the centimeter, what is the change in temperature, or delta T? So delta T is what we're trying to figure out. So our first step is figuring out what formula we need to use. Well, we know that Q is equal to mass times specific heat times delta T. And so using this formula, instead of solving for the heat absorption Q, we need to kind of reorganize this equation to solve for a delta T, or a change in temperature. So our second step is just kind of looking at what we have in the equation, if we need to make any conversions and whatnot. And we know that since our specific heat value is in joules per gram, that we have a 1.5 kilogram sample. So the first, or I guess, second step is we need to convert that 1.5 kilograms into grams. So you can see here in our unit conversion, we have 1.5 kilograms that we're multiplying by 1,000 grams over 1 kilogram to cancel out those kilograms. That gives us 1,500 grams of H2O. And so the third step is then just plugging these numbers into the equation and kind of reorganizing this so we can find our delta T. So the first step is just to get our 2.0 times 10 to the 4th joules of heat absorption times our mass and specific heat, solving for delta T. So once we have this, we obviously have this. We multiply these two together to equal 6,276 times our delta T. Well, all we have to do now is take our specific heat, divide that number by this to get our delta T. And when we do this, we end up with 3.18674 degrees Celsius for our change in temperature. Now, remember in our sig figs that we have used 2 sig figs here, there's 2 sig figs here, there's 4 sig figs here, so in this equation we have multiplied, so we would have 2 sig figs here, 2 sig figs here, we divide, so we still have 2 sig figs, and so that is going to give us 3.1, and we have this 8 here, so we're going to round up to that 1 up to a 2. So that is going to equal 3.2, so our delta T, our change in temperature, due to a heat absorption of 2.0 times 10 to the 4th joules of water, we have a temperature change of 3.2 degrees Celsius.